Hi, I'm Stephanie from DesignCode. In this tutorial, we're going to learn how to build a chat application from scratch using Firebase Firestore. In this application, we'll be able to read and write to Firestore with real-time updates, meaning that when we add a new message to our database, the messages in this application will be updated instantly. So let's see how to build that. Once our Xcode project has been created, we'll update the assets folder in Xcode by adding a custom icon to our application, as well as custom colors. Next, we'll code the UI. We'll need to create a few components to complete our chat view. First, we'll need to code our TitleRow, which contains our friends' information, as well as a phone icon on the right side of the screen. Then we'll need to create our MessageBubble, which will have a different background and will be aligned either to leading or trailing depending on if the user received the message or sent that message. We'll also need to code one last component, which is the message field at the bottom here, and we will customize our text field so that it looks nice like this. Once our UI is done, we'll tackle everything related to Firebase. We'll create our Firebase project, connect Firebase to our iOS app. We'll also add the Firebase SDK and code a few functions to read and write to Firestore. To follow this tutorial, make sure you have Xcode 13 installed on your computer because we'll be using some new features introduced in iOS 15 and it's only available in Xcode 13 or higher. So without further ado, let's start. First, we'll need to create our Xcode project. In the model that appears when you launch Xcode, click on Create a new Xcode project. Make sure that you're under the iOS tab and select the app under the application section. Then click on Next, and you'll need to give your product a name. So I will give it Chat App Demo. Select your theme, and your organization identifier is the reverse of your domain name. In our case, our domain name is DesignCode.io, so by reversing it, it becomes io.designcode. Make sure the interface is SwiftUI and the language is Swift. Usually, these are the default values, so you don't need to change them. Then click on Next, and choose where you want to save your project. Then click on Create. When creating a new Xcode project, the first thing I like to do is to close this panel and to change my simulator to iPhone 13. Then I resume the preview in Content View to make sure that I successfully created my project. Great, so when you see the Hello World screen, it means that your project has been successfully created. Let's go to the Assets folder and we will need to update our app icon and add a few custom colors to our project as well. So for the app icon, simply create an app icon for each size that is specified here and then simply drag and drop it into their corresponding slot. Once you added an icon for each empty slot under the app icon folder, we'll need to add two custom colors. So still under the Assets folder, right-click and create a new color set. The first color we'll add will be a gray. So let's write gray. And this application won't be adapted for dark mode because we want to keep this tutorial short. So we'll simply need to set our any appearance color. So click on that, then open the Attributes Inspector. And at the bottom, click on Show Color Panel. Make sure that you're under the RGB Sliders tab, and at the bottom here, you'll be able to set a custom hex color. So you can set any grade that you wish, but in my case, I will set it to the hex color EB. Then if I hit enter, you will see that the white color has been changed to our gray color. You can't really see it now, but you'll see it later on in our UI. The second color we'll add is a peach color. So right-click again and create a new color set, and this color will be called peach. Similar to the gray color, we won't need to set our dark color, we'll simply set an any appearance color. Open again the color panel, and still under the RGB sliders, we'll set our custom hex color. This time it will be FFD8C4. Hit enter, and you'll see that our peach color has been updated. Now that we're done with the Assets folder, we'll need to create our TitleRow. So under the Chat App Demo folder, right-click and create a new group. This group will be called Components. I'll just drag and drop it before the Assets folder, and I will right-click on the Components folder and create a new file. This will be a SwiftUI view, and we'll name this title row. Then click on create. The title row component is this row here, which contains our friend's profile picture, their name, their online status, as well as the phone icon on the right side here. So at the top of this view, we will need to add two variables. The first one will be an image URL. We'll take a URL from the internet, so we'll need to create a URL from the URL string. In my case, I went on unsplash.com and I searched for a portrait. And you can see that we have a lot of portraits here that we can use. So in my case, I used this link here, which is the same image as this one, and you can take any picture that you want. Next, we'll create a variable called name and we'll give our friend a name. In my case, I will name her Sarah Smith. In the body of our title row, let's remove the text hello world and add an age stack instead. We'll have a spacing of 20 pixels between each element in our age stack. Since we're using an image from the internet, we'll use the async image to load the image into our application. So write async image, and it will require a URL, which will be the image URL variable that we created on line 11. Then we can get the image inside of the closure to modify the image a bit. And don't forget to also add the placeholder closure with a progress view so that Xcode doesn't complain. Inside of the image closure, let's call our image and then add the resizable modifier. Next, we'll also add the aspect ratio modifier with content mode that will be .fill. We'll also add a frame with a width of 50 pixels and a height of 50 pixels as well. Finally, we'll add some corner radius of 50 pixels so that our image is a perfect circle. If I play on my preview, you will see our image has been loaded into our application. Right below this async image, we'll add a VStack with some alignment to leading. Inside of this VStack, let's add a text with our friend's name and change the font to title and make it bold too. Right below this name, we'll add an online word that lets us know our friend is online. So it will be text, which will be a string, and we'll say online. The font will be caption, and the foreground color will be gray. Next, below this VStack, let's add an image from a system name, and we'll be using the phone.fill SF symbol. So let's write phone.fill, and we'll change the foreground color of this image to gray with some padding of 10 pixels all around the image. We'll also add a background that will be white and a corner radius that will be 50 pixels as well. So right now we can't really see the circle surrounding our phone icon because it's white on white. So we can scroll down to the preview and add the background modifier to our title row instance here. So we'll pass the peach color that we added in the assets folder. Great, so right now you can see that our title row doesn't take the entire width of the screen. To fix that, we will add a frame to our VStack with a max width of infinity and an alignment to leading. And on our H stack, we'll add some padding so that we have some padding all around our row. Great, we're finished coding our title row. Let's go to content view and we'll be calling our title row here. So let's remove the text hello world and add a VStack. Inside of the VStack, we'll call our title row. We'll also add a background color to our VStack and it will be of color peach. Now we'll need to create a message model. So right-click the chat demo folder and create a new group. This group will be called models and I will drag and drop it before the components folder. Then right-click the models folder, click on new file, and it will be a Swift file. This file will be called message. In this file, we'll create the structure all messages we'll create must follow. So let's create a struct called message, which will conform to the identifiable protocol, which means that each message can be uniquely identified with its ID. And it will also conform to the codable protocol. And you can see here that a codable means that it's decodable and encodable. So that means that we can convert the data that we fetch from Firestore into this model, and we can convert it back again into the Firestore model. then add a closure, and inside of the struct, we'll add 4 variables. The first one is an ID, which will be a string, then we'll have a text, which will also be a string, and we'll have a receive state, which will be a boolean. For the receive state, if the user is the sender of the message, the receive state will be false. If the user is the receiver of the message, then the received state will be true. And finally, we'll have a timestamp, which will be of date type. Great, now that we have our message model, it's time to create our message bubble. The message bubble is this here or this here. So depending on if the user is the receiver of the message or the sender of the message, the background color will be different and the alignment as well. So under the components folder, right click, create a new file. It will be a SwiftUI view, and let's call this MessageBubble. Then click on create. The MessageBubble component will accept one argument, which will be a message, and it will be of message type. So the message type here is the model that we just created in the message file. You might see that right now Xcode is complaining that it's missing an argument for parameter message in call for the preview. So to fix that, we just need to pass a message and create an instance of message. So for the string, I will simply write 1, 2, 3, 4, 5. And for the text, you can write anything you want, but I'll write, I've been coding SwiftUI applications from scratch, and it's so much fun. The receive state is false because we are the one who sent this message, and the timestamp, since it's a date, will simply initialize a date and it will be today's date. For the body of the message bubble, let's remove the text hello world and add a VStack with an alignment. So for the alignment, we want it to be leading if the user received the message and trailing if they sent the message. So we'll check the message.receive state. If it's received, we will have an alignment to leading, otherwise we'll have an alignment to trailing. Inside of the VStack, we'll add an HStack, and the HStack will contain the text, and the text will be the message.text, so the contents of our message. Then let's add some padding all around our message with a background color. And the background color is different too, depending on the received state. So let's check message.received. If it's received, the color will be the gray color that we added in our assets folder. Otherwise, it will be the peach color that we also added in our assets folder. We'll also add some corner radius of 30 pixels on our message bubble. Now, if the message is too long, we don't want the message to go over a certain width. So on the HStack, let's add a frame with a max width of 300 pixels. And we'll also add some alignment. So if the message has been received, the alignment will be to leading, otherwise it will be trailing. Great. Now on the VStack, we'll add a few modifiers as well. So we'll add a frame with the max width of infinity and an alignment as well. So we'll also check if the message has been received. If it is, the alignment will be leading, otherwise it will be trailing. We'll also add some padding, and we'll check again if the message has been received. If it is, the padding we'll add will be leading, otherwise it will be trailing. And let's just add some more padding horizontally. So padding horizontally and 10 pixels. Great, now when the user taps on a message bubble, we want to show the time here. And when they tap again, the time will be hidden. At the top of the message bubble component, we'll add a state, private var, which will be called showtime, and it will be equals to false by default. On the HStack, we will add an on-tap gesture modifier. So on-tap gesture, and when the user taps on that, we want to call our showtime and toggle its value. Then right below this HStack, we want to check if showtime is true. If it's true, we will show the time. So we'll add a text, and we need to add double quotes with a string interpolation because we will be adding a date inside of the text, and the text only accepts a string. So we'll call message.timestamp, and we'll call a new function since iOS 15 called formatted, and it easily formats the date for us. So we'll call .datetime, and we just want to show the hour as well as the minute. So let's test out this code. Great. However, you can see that our time is a bit too big. So let's add a font of caption 2 with a foreground color of gray. And we'll also add some padding. So we'll check if the user has received this message. If it is, the padding will be leading, otherwise it will be trailing, and the padding will be of 25 pixels. Great, so right now you can see our time at the bottom of our bubble. Let's test out the receive state being true instead of false. So you can see that our bubble has been aligned to leading instead, and when we tap on the message bubble, the time will be shown on the left side. Great, so our message bubble has been completed. Let's go back to content view and we'll add a few message bubble to this view. At the top, we'll create an array of messages, and this is only temporary because we will use the data we will fetch from Firestore later on. So var message array, which will be an array of strings. So inside you can write a few strings. Hello you, how are you doing? And one last message. I've been building SwiftUI applications from scratch, and it's so much fun. Now in the body of content view, right below the title row, we will create a scroll view. Inside of this scroll view, we'll iterate over the messages array, and the ID will be .self. What we get in the closure is a text, and we'll call our message bubble. For the message, we'll create a new message instance. So the ID will be 1, 2, 3, 4, 5. The text will be the text that we're iterating through. For the receive state, let's write true, and timestamp, it will be date. Great, let's add some modifiers to our scroll view. So we'll add some padding at the top of 10 pixels, and we'll also change the background of our scroll view to white. We also want to add some corner radius to only the 2 top corners of our scroll view. So let's create a new file under the chat app demo, and we'll create an extension. So it will be a Swift file, and we'll call this extensions. I have my code here, and you can find it in the text content of this tutorial, or you can also find it in the GitHub repository of this tutorial. Basically, what we're doing here is we're creating an extension on Vue, and we're adding a new modifier called corner radius. And this corner radius will be different than the default corner radius from SwiftUI, meaning that we can add a radius, and we can also select the specific corners on which we want to add a corner radius on. Let's go back to content view, and on the scroll view, we will add our new corner radius that we created, the one with the corners argument. For the radius, we will add 30 pixels, and for the corners, it will be an array, and we want the top left as well as the top right corners. Great, so you can see that the top right and the top left corner are rounded, but not the bottom ones. Finally, we need to code our last component. The last component is the message field that you see at the bottom here. So if you already worked with the text field from SwiftUI, you know that it's not really easily customizable. So we'll need to create a custom text field first so that we can customize it like this. Let's go back to Xcode, and under the components folder, right-click, create a new file. It will be a SwiftUI view, and we'll call it MessageField. Then create it. So as I mentioned, we'll need to create our custom text field. Under the MessageField preview, we'll create a new struct called custom text field, and it will be a view. This custom text field will have a few variables. The first one will be a placeholder, which will be a text. Then we'll also have a binding value for text, which will be a string. A binding means that we can pass a variable from one view to another and modify that variable outside of that view. Then we have a var editing change, which will be equals to this. And finally, we have a comment, which will be this here. Next, we'll also have a body, which will be some view. And inside of the body, we'll add a VStack with an alignment to leading. Inside of the VStack, we want to check if the text is empty. So the text is what the user inputted in the text field. So if it's empty, we'll add our placeholder with some opacity 2.5. Right below this if statement, we'll add a text field. And for the placeholder, we'll just add an empty string. The text will be a binding value, so we need to add a $sign and then call our text. We also need to pass the on editing changed and the on commit. So the on editing change will be the editing change state, and we also have the on commit, which will be the commit state. So you can write this code from scratch, or you can just copy it from the text content of this tutorial, or you can also find it in the GitHub repository of this tutorial. Now let's go back to our message field structure. At the top, we'll need to create a state private var, and it will be a message, which will be an empty string. So this is the state that will change when the user inputs something in the message field. Now, let's remove the text hello world in the body and add an age stack instead. Inside of the age stack, we'll call our custom text field, and it needs a placeholder and text that are required. So for the placeholder, we'll add a text and we'll say, enter your message here. For the text, since it's a binding string, we will add the $sign and call the message state that we just created on line 11. Right below this custom text field, we'll add a button. The button has two closures, so the first one is the action and the second one is the label. Let's take care of the label first. So we'll add an image, and it will be an image from SF Symbols. We'll take the paperplane.fill. Instead of having it blue, we'll change the foreground color to white. And we'll also add some padding of 10 pixels. So right now you can see that it's white on white. So let's add a background, and it will be the peach color that we added to our assets folder. Great, so now we can see our button better. Next, we'll also add some corner radius of 50 pixels so that it makes a circle. For the action of the button, we'll just print a message sent to the console, and we'll also reset the message to an empty string once it has been sent. Now on the age stack, we'll have to add a few modifiers. So first, we'll need to add some padding horizontally. Then we'll add also some padding vertically of 10 pixels. We'll change the background color to the gray color that we added to our assets folder. Next, we'll add some corner radius of 50 pixels as well, and some padding all around our age stack. Now let's go back to content view and we'll add our message field here. So we'll need to wrap our current VStack in another one. So click on Common on your keyboard and click on the VStack, then embed this in a VStack. Right below the child VStack, so below the background color peach, we will call our message field. Great, so now you can see that we have our message field here. Great, we finished coding the base of our UI. Let's tackle the Firebase part now. But first, what is Firebase? Firebase is an all-in-one platform that allows us to build, grow, and engage your audience with your application. In this tutorial, we'll only be using Cloud Firestore, which will act as our database. So first things first, we need to create our Firebase project. So head over to the Firebase console, so you can click on Go to Console here, or you can simply directly go to the console.firebase.google.com link. Then click on the first card to add a project. On the next page, you need to give your project a name. So I will name it Chat App Demo. Then click on Continue. You'll then be asked if you want to enable Google Analytics for your Firebase project. In our case, we don't need Google Analytics, so we will disable it. Then click on Create Project. Once your project has been created, click on Continue, and you will be redirected to your project overview. We'll first need to create our iOS app. So click on the iOS option that you see in the blue banner here. And you can see that we have 4 steps to follow, and the 5th step is only to redirect you to the console. The first thing we need to do is to register our application. The only required field in this form is the Apple Bundle ID. If you don't remember what your bundle ID is, simply head over to Xcode, click on your project name. Then under Targets, General, you will see under the Identity section your bundle identifier. So simply copy this, go back to your browser and paste it in the Apple Bundle ID section. If you want, you can give your app a nickname, or you can also provide the App Store ID, but we won't need it in this tutorial. Then click on Register App. The second step is to download the Google Service Info Place file. So click on Download, and this file contains all the necessary data to link your Firebase project to your Xcode project. Go back to Xcode, open your Finder where you downloaded your Google Service Info Place file, and drag and drop it into the root folder of your project. Then I will leave this option as is and click on Finish. So you can see that I added my Google Service Info Place file under my Chat App Demo folder. Make sure that it's in the root folder of your project. Let's go back to our browser and click on Next. And you can see that we're now at the third step, and it tells us to add the Firebase SDK to our Xcode project. We'll use the Swift Package Manager way since it's easier. So we'll just copy this link to the Firebase GitHub repository, then head back to your Xcode project. Click on your project name, then under Project, click again on your project name, and click on Package Dependencies. Click on the plus sign at the bottom to add a package dependency to your project. In the search bar at the top right corner, paste the link to the Firebase GitHub repository, and Xcode will find this repository for you. For the dependency rule, set it to next major version, and for the add to project, leave it as is. Then click on Add Project. Xcode will fetch the package for you. It might take a few minutes. Once the packages has been fetched, you will need to choose the package products that you want to add to your project. So scroll down and search for Firebase Firestore. Check the box, and we'll also need the Firebase Firestore Swift Beta. This second package is necessary to convert the Firebase data into our message model that we created in our project and back again. Then click on Add Package, and Xcode will fetch the packages for you. You might see that we have a lot of package dependencies here, but that's normal. They're all from the Firebase package. Now let's go back to the browser and click on Next again. And you can see that we are now at the step where we need to initialize our Firebase instance in our application. They're suggesting us to use the app delegate way, but there's a simpler way. So let's go back to our project, click on our Chat App Demo app file, and in this file you will see your structure, which conforms to an app, and you can also see the @main on line 10. At the top, we will need to import Firebase. Then inside of our structure, right before our body variable, we will add an init, and inside of the init, we will call our Firebase app.configure. So that is telling Xcode to configure our iOS application with the Firebase app that we created in our browser. Now go back again to the browser, click on Next, and now you can see that we're all set. So let's continue to console. Great, we created our iOS app in Firebase and connected everything to Xcode as well. We now need to create our Firestore database, which is what we'll use as our database to save our messages. So click on Firestore database, and in the banner, click on Create Database. A model will be prompted, and you'll need to set the settings for your Firestore database. So first, you'll need to set the security rules for your database. We will start in test mode instead of production mode, so that we can easily read from and write to our database for 30 days. However, remember that if you ever push your application to production, you should edit your security rules so that not everyone can read and write to your database, because it's a big security flaw. Then click on Next, and you'll need to set the location for your Cloud Firestore. This is where your Firestore database will be physically located. Once you set it, you cannot change it. So I will leave it as is, then I will click on Enable. Now it's time to add data to our Firestore database. If it's your first time using Firestore, I highly encourage you to read this documentation page to better understand the Firestore data model. You can also watch this YouTube video introducing Firestore. Basically, Firestore works in collections, documents, and data. The collection is similar to a folder containing the documents, which are the papers, and on each document, we have the data. Let's go back to Firestore, where we'll just add a few messages following the message model we created before in Xcode. So click on Start Collection, and we need to give our collection a name. So let's give it Messages. Then click on Next. Then we'll need to create our first document. So each document must have a unique ID. In our case, we'll simply use the auto ID generated by Firestore. And we'll need to add a few fields to our document. The first one is the ID. So let's just copy the ID from the document ID. Then click on the plus sign to add a new field. And we'll add a text, which will be of type string. And the value will be hello, Sarah. You can write whatever you want in the text. The next field will be the receive state. It will be a Boolean value, and it will be false because we are the sender of this message. Finally, we have a timestamp, which will be of timestamp type. Then we can set the date to today's date and the time. Right now it's 10:39, so 10:39, and click on Save. You can now see that we have our messages collection, we have one document, and the necessary data in our document. Repeat the process a few times by clicking Add Document, Auto ID, and add the same 4 fields to your document. So the ID, then the text, hey there, next a receive state, which will be a Boolean value, and this one will be true. And finally, we have our timestamp, which will be of timestamp type. We'll set it to today's date, and it will be 10:40 a.m. Add at least 2 documents so that we can test out the received and sent message bubbles in Xcode. If you want, you can add more than 2. So in my case, I added 4 messages so that it feels more like a real chat history. Now let's go back to Xcode, and we will need to call this data with real-time updates. So under the chat app demo folder, right-click, create a new file, and it will be a Swift file, and let's call this Messages Manager. Then click on Create. In this file, we'll manage everything related to our messages. We'll read the data from Firestore in real time and write to our database as well. Inside of this file, let's create a class called Messages Manager, which will conform to the Observable Object Protocol. At the top, after importing Foundation, we'll also need to import Firebase Firestore, as well as Firebase Firestore Swift. Then inside of this class, we'll need to create 2 variables. The first one is a published private set var messages, which will be an array of message, and we'll initialize it to an empty array to begin with. Next, we'll need to create a DB instance, which will be Firestore with parentheses at the end. So this refers to our Firestore database, and we're creating an instance of it in this class. Next, we'll need to create a getMessages function. Inside of this function, we'll call our database, then call the collection messages, which is our collection that we created in Firestore. Then we will add snapshot listener. And inside of the closure, we will get a query snapshot, as well as an optional error. The first thing we'll do inside of this closure is to add a guard statement. So we want to make sure that we have documents in our query snapshot first. So we'll check if guard let documents equals to query snapshot.document, else we'll print our error. So error fetching documents, and we'll print our error that we get from Firestore, and then we'll return. So right now we can see that we have 2 warnings here. The first one is that the documents is not used, but we will use it later on. And the second one is that the string interpolation produces a debug description for an optional value. Let's simply click on the first suggestion to add string describing, and this will silence the warning. Right below this guard statement, let's call our documents, which is the variable that we created on line 18, and we will call the compact map. The compact map is similar to a map, but it will only return the non-nil values of the documents array. Inside of the closure, we get a document, and we will return an optional message, because if we ever run into an error, we won't return a message. Then on the next line, let's do a do catch, because we will need to use a function that might throw an error. In the catch, let's print error decoding document into message, and we'll print the error. And we'll also return nil if we ever run into an error. In the do, return, and we'll try document.data as message.self. So this line of code means that we'll take the document and get the data on this document and transform it into the message model that we created in the message file. Note that the data as function comes with the Firebase Firestore Swift package, so remember to import it in this file. You can see that we still have a warning, which tells us that we're not using the result of our compact map. So let's save it into our messages array, and remember to add a self before, because we're in a closure. When you're in a closure, you always need to add the self keyword when you're referencing to a variable in your class. Now we'll need to call this getMessages function on initialize of our class. So let's add the init here, and we'll call the getMessages. Now it's time to test out the getMessages function and see if we do get the messages from Firestore. Go to Content View, and we'll initialize an instance of Messages Manager as a state object. So at state object var Messages Manager will be equals to Messages Manager with parentheses at the end, so that we initialize this class in Content View. Now, instead of iterating over the messages array, we will call our Messages Manager dot messages array. So these are the messages that we added in Firestore. And for the ID, instead of self, we will replace it by the ID of each message, and instead of a text, we get a message in the for each loop. Since we get a message and the message is already an instance of the message model, we will remove the instance of message that we created and passed to our MessageBubble, and we'll pass the message that we're iterating through instead. So right now you can see that we have our messages in our view. However, you can see that the messages are not ordered by the sent date. So the first message that I sent was hello Sarah, so it should be at the top of this view, and then it should be hey there, and the next message is what have you been up to lately, and the last message is this one. Let's go to Messages Manager, and we can sort the messages two-way. We can either use the sort method or the sorted method. The difference is that the sort function will change the original array itself, while the sorted function will create a new array and return that new array. The sorted function uses more memory than the sort, so we'll use the sort function. Back in Xcode, in Messages Manager, right after our compact map, we'll do self.messages.sort, and we'll add curly brackets. Then we'll write $0.timestamp is smaller than $1.timestamp. So that will sort our messages by timestamp from the oldest date from the newest date. Now let's go back to Content View. I will pause my preview and play it again. And you can see that my messages has been updated, and it follows the time each message has been sent. So we're not using the messages array anymore, so we can remove this in Content View and build your application in the simulator. Once your application has been built, you can see that our messages are ordered correctly now in our view. So the first message has been sent at 10:39, then 10:40, 10:40 again, and the last one was sent at 10:44. So great! Now it's time to test out our real-time updates with Firestore. So we'll be adding a document in Firestore and see if a new message pops up in our view. So let's add a new document with auto ID. The ID will be the ID of the document. Then we have a text. Let's write, what kind of books are you reading? Next we have a receive state, which will be a Boolean value, and it will be false because I am the one sending out this message. Finally, we have a timestamp, which will be a timestamp type. We'll set it to today's date, and let's set it to 10:50 a.m. Then click on save. And you can see that a new message popped up in my view and it was sent at 10:50 a.m. So great! Now it's time to take care of the message field here and send an actual message from our application. Let's go back to Xcode and we'll take care of the sending message part. But first we can stop our application running in the simulator. Then right below the getMessages function, we'll create a new function called sendMessage, and it will require an argument, which will be a string. Inside of this function, let's add a do_cat statement because we'll be using a function from Firestore which might throw an error. So if we get an error, we'll print error adding message to Firestore and we'll print the actual error. Then inside of the do, we'll need to create a new message instance. So let new message will be equals to a message instance. So we'll need to provide an ID, a text, a receive state, as well as a timestamp. For the ID, we will add double quotes and we'll create a UUID, which is a random ID generated by SwiftUI. Next, we have the text, which will be the text that we pass to this function. We'll also have a receive state, and the received Boolean value will always be false because I'm always the one sending out the messages when I'm using this application. And finally, we have a timestamp, which is a date. So we simply need to initialize a date instance here. Then right below this new message, we'll try db.collection messages because we want to save our documents under the messages collection. And we'll create a document and set the data from the new message variable that we created on line 43. So the set data will convert the new message into Firestore data. And you can see now that we have an error here because I forgot to initialize the UUID with parentheses at the end. So remember to add it. Now that we have our function, it's time to call it in our view. So let's go to the MessageField component and we'll need to add an environment object to this view. So add environment object var messages manager, which will be of messages manager type. Remember to add the environment object modifier to the preview as well and create an instance of messages manager here. Don't forget to go to content view and also pass the environment object modifier to our MessageField instance here and pass the messages manager state object that we created on line 11. Now let's go back to the message field and instead of printing the message saying that the message has been sent, let's call our messages manager dot send message and we need to pass a text which is the text that the user inputted in the message field. Luckily, we saved it in the message state on line 12, so we simply need to pass that. Great, now it's time to test out our application. Click on the play button here to build it in the simulator. Once it has been built, write your message. I will write, I've been building SwiftUI applications from scratch and it's so much fun with an exclamation mark. Then I will hit on the send button and you can see that a new document has been added to my Firestore and it's the last message that I sent in here. However, we have a problem. So I will send another message to Sarah in my application. I've just built a chat application from scratch using Firebase Firestore, and there's also real-time updates. It's amazing. Then I will hit on send. You can see that my message has been sent, but it didn't scroll to the last message in my view because my chat height is actually higher than the height of my scroll view. So luckily, there's something called a scroll view reader, and we can use that with its function scroll to scroll to a specific item in my scroll view. So let's go back to Xcode, and in content view, we will wrap our scroll view in a scroll view reader. So click on command on your keyboard and then click on scroll view, then embed this in any stack that you want. And we'll change this stack to a scroll view reader. If we take a look at the documentation, inside of the closure of the scroll view reader, we get a proxy. So let's add that. Proxy in. Then we will need the ID of the last message so that we can scroll to that last message in our scroll view. So we'll do all the logic related to getting the last ID in our messages manager. At the top, create a published private set variable called last message ID, which will be equals to an empty string to begin with. Then in the getMessages function, after the sort, we will add self.messages.last.id. However, you can see that we have an error because when we get the last message from the messages array, it's an optional. So let's add a question mark after last, and we'll need to unwrap that optional. So we'll do if let id equals to self.messages.last.id. Then we will set the last message ID will be equals to the ID that we unwrapped on line 39. Then let's go back to content view, and on our scroll view, after the corner radius, we will need to add the onChange modifier. We will check the messages manager dot last message ID and we'll perform something with the new ID. So every time that this ID changes, we will call proxy.scrollTo. And you can see that the scrollTo function requires two arguments. The first one is the ID, so we simply need to pass the ID that we get inside of this closure. And the anchor of the scrollTo function is the alignment behavior of the scroll action. So we want to scroll to the bottom, so let's write bottom. We will also want a bit of animation when we scroll to the last message. So let's add with animation and move the proxy scroll to inside of the with animation closure. Now let's stop our build in the simulator and play it again. So it builds again our application with the new code that we added. And you can see that once our application has been built, by default, it's already scrolled to the bottom, so to the latest message of our conversation. Let's test it out again. So we will add a new document in Firestore. You can do it in Firestore or you can send another message from the application again. But I want to add a message that Sarah has sent me. So the text, and I will say, that sounds like so much fun. You should show it to me next time we see each other. Then we also have a receive state, which is a boolean, and it will be true because Sarah sent me this message. Finally, we have a timestamp of type timestamp. Let's set it to today's date, and right now it's 12:10, so I'll set it at 12:10. Then I will click on save, and take a look at the application here because it will be updated and it will automatically scroll to the last message of our conversation. So you can see that it scrolled to the last message. Great! We've finished coding our chat application using Firestore as our database. We coded different components that make up our view. So we coded a TitleRow, a MessageBubble, as well as a MessageField. We also created a message model that conforms to the identifiable and the codable protocols so that it allows us to convert the data we fetch from Firestore into that message model and back again into Firestore data. In our messages manager, we use the add snapshot listener function to get real-time updates from Firestore so that when we add a new message in our database, our application will be instantly updated. Now go ahead and build amazing chat applications of your own.